Okay, so in this video, we're going to talk about geometric sequences. So I think the first thing that's important to remember is the difference between a geometric sequence and an arithmetic sequence. So if we have the numbers 256, 128, 64, 32, we're looking for the common difference or the ratio between the two. So we can do this by putting 256 under 128 and simplifying it to find what the common ratio is. We can divide both of them by 128 and that gives us 1/2. Next would be 64 over 128. We could simplify that to 1/2. 32 over 64. We could simplify that to 1/2. So 1/2, 1/2, 1/2. So our common ratio is 1/2. That makes it a geometric sequence. Now, let's look at these numbers. 4, 9, 12, 18. We're putting 9 over 4. So between this is 2 and 1/4. Now between 12 and 9. It's 1 and 1/3, right? What about between 12 and 18? 1.5. None of those are in common, so we're going to go with neither for that one. Wait, let's check and see if it's arithmetic. It's not geometric. So let's go 4, 9, 12, 18. Getting a little ahead of myself. 4 to 9 is plus 5. 9 to 12 is plus 3, plus 6. Again, none of those are the same, so now we can confirm that it's a neither sequence. Let's try this one. We have -20, -15, -10, -5. We're going to start -15 over -20. Negative makes it positive. Divide both by 5. That gives us 3 over 4. -10 over -15. Positive over positive. That gives us, divide each side by 2. Positive 2 over 3, right? So we can already see not a common ratio. What about if we try for an arithmetic sequence? We're adding 5, right? Adding 5. Adding 5. Because there's a common difference between each one, that makes it an arithmetic sequence. So let's just look here. Geometric. Neither. Arithmetic. Does that help us kind of understand the difference between all of them? Good. Okay, now again, we can take what we did here and we can find the next two terms in the sequence. So if we're looking at this one, we have 256, 128, 64, 32. So we're taking half of each of the numbers before that. So we're taking 32 and we're multiplying that by 1/2. Whoa, that should be a 2. So 32 over 1. So we're doing 32 over 2, which is 16. So our next number, so the fifth in our sequence would be 16. Now to find the sixth term, the next one, if we needed the next two terms, we would do 16 over 2, which would give us 8. So we can find the next two terms in this geometric sequence by continuing to use the ratio. Same thing with this arithmetic sequence. We're adding 5 each time. So if we added 5 to -5, we would get 0. So that would be the next term. And then if we add a 5, we get +5. So this would be the fifth term. This would be the sixth term if we were asked to find the next two terms. Now we need to look at this up here. So this is our formula for finding the nth term of a geometric sequence. So if we have -6, +12, -24, +48. And they're asking us to write the equation for the nth term. So if we're solving for this, we're using our first term is 6. We can figure that out pretty easily, right? So -6. Now we need our common ratio. So we're going to put 12 over -6, which is going to give us -2. Check and make sure that's right. 24 over 12, it's going to give us -2. If we have -2
A -2?
as our common ratio, then we can plug that in for r. Then n is our positive integer. So we need to know which term are we solving for. If we know that, we're plugging that in for n. If not, then we're leaving it as n. So we're doing a to the n equals a1, which is -6, times r, which is -2 to the n minus 1. And that would be our equation for this geometric sequence. Then if it told us to find the 9th term, now we would be doing -6 times -2 to the 9 minus 1. So -6 times -2 to the 8th. We would solve -2 to the 8th and then multiply that times -6 to figure out what our 9th number was.